Jai Hind, myself Dr. Alok Vardhan. Currently, I am working as an assistant professor in the Department of Mechanical Engineering in Ajay Kumar Garg Engineering College, Ghaziabad. Today, I will discuss one of the important topic of the subject fluid mechanics and fluid machines. And the topic is Introduction to Fluid and its Properties. So, basically, in this lecture, I will cover following topics. First of all, I will discuss what is fluid mechanics, then what is fluid, then different properties of fluids, in which I will discuss what is density, specific gravity, mass density, and so on. Then I will discuss what is viscosity, then Newton's law of viscosity, then variation of viscosity with respect to temperature, then what is compressibility and bulk modulus, then what is surface tension, pressure, Pascal's law and continuity equation. So, what is fluid mechanics? So, basically fluid machine is that branch of fluid mechanics is that branch of science which deals with the behavior of fluids either at rest or in motion. So, basically the study of whole fluid mechanics is divided into these three parts: fluid statics, fluid kinematics and fluid dynamics. So, what is fluid statics? The study of fluid at rest, which comes under fluid statics. Then the study of fluid in motion, where pressure forces are not considered, is called fluid kinematics. But in fluid dynamics, the study of fluid in motion, where pressure forces are also considered, so this area is called fluid dynamics. Then what is fluid? So, basically a fluid is a substance which is capable of flowing or deforming or moving under the action of shear force. When there is no shear force, the fluid will be at rest. Fluid includes liquid as well as gases. So, for liquid, water, oil, kerosene, etc., and gases, air, vapor, or comes under fluids. Then what is different properties of fluid? So, the first property is density or mass density. What is density or mass density? Basically, it is defined as the ratio of the mass of a fluid to its volume is called density or mass density. In other words, we can say that mass per unit volume of a fluid is called density, and it is denoted by the symbol rho. The unit of mass density in SI unit is kg per meter cube, whereas in CGS unit is gram per centimeter cube. And mathematically we can say that density is the ratio of mass of the fluid to its volume, and for water we can take density for water as 1 gram per centimeter cube or 1000 kg per meter cube at temperature 4 degree Celsius. Then second property is specific weight or weight density. What is specific weight or weight density? Basically, it is defined as the ratio between weight of a fluid to its volume. In other words, we can say that weight per unit volume of a fluid is called weight density, and it is denoted by symbol small w. So, mathematically we can say that specific weight is the ratio of weight of the fluid to its volume, and we know that weight is the product of mass of the fluid in and acceleration due to gravity. So, mathematically we can write specific weight is equal to mg upon v, but m by v is rho. So, we can write specific weight is equal to rho g. So, for water, specific weight or weight density is equal to 9.81 into 1000 Newton per meter cube. Then the third property is specific volume. So basically, specific volume of a fluid is defined as the volume of a fluid occupied by a unit mass, or volume per unit mass of a fluid is called specific volume. Yeah, mathematically we can say that specific volume is the ratio of volume of a fluid to its mass, and we know that specific volume is also equal to 1 by rho, where rho is the mass density or density of the fluid. So we can say that specific volume is the reciprocal of mass density, and its unit is meter cube per kg, and it is commonly applied to gases. Then the next property is specific gravity. What is specific gravity? Basically, specific gravity is defined as the ratio of weight density or density of a fluid to the weight density or density of a standard fluid. For liquid, the standard fluid is taken as water, and for gases, the standard fluid is air. So we can say that specific gravity also called relative density, and it is a dimensionless number denoted by symbol capital S. So mathematically we can say that specific gravity is equal to weight density or density of a liquid to the weight density or density of water. Yeah, for gases, weight density or density of gas to the weight density or density of air. So it is a dimensionless number. Now I will discuss what is viscosity or dynamic viscosity. So basically, viscosity is defined as the property of a fluid which offers resistance to the movement of one layer of fluid over another adjacent layer of the fluid. So basically, viscosity is the internal resistance offered by one layer of fluid to the other. And mathematically we can say that shear stress tau is directly proportional to du over dy, where du over dy is the velocity gradient, and if further we solve this equation, we get tau is equal to mu du over dy, where mu is the viscosity or dynamic viscosity. So basically, it is nothing but it is the internal resistance offered by one layer of the fluid in other layer. What is the SI unit of viscosity? So SI unit of viscosity is Newton second per meter square, या dyne second per centimeter square, and in CGS unit, the SI unit of viscosity is Newton second per meter square, and CGS unit is dyne second per centimeter square, also known as poise, and 1 poise is equal to 1 gram per centimeter second या 0.1 kg per meter second. So in other words, we can say that 1 Newton second per meter square is equal to 10 poise. Then what is kinematic viscosity? Basically, kinematic viscosity is defined as the ratio between the dynamic viscosity and density of fluid. It is denoted by the Greek symbol nu, called nu, and mathematically kinematic viscosity is written as viscosity mu upon density rho, and its MKS and SI unit is meter square per second, whereas CGS unit is centimeter square per second, which is known as Stokes, and 1 centimeter per second is equal to 1 Stokes, and 1 meter square per second is equal to 10 to the power 4 Stokes. Then what is Newton's law of viscosity? So basically, Newton's law of viscosity states that the shear stress tau on a fluid element layer is directly proportional to the rate of shear strain d theta over dt or velocity gradient du over dy. So mathematically, Newton's law of viscosity expressed as tau is equal to mu du over dy या mu d theta over dt, where mu is the viscosity, and d theta over dt is the rate of shear strain, या du over dy is the velocity gradient. So, according to Newton's law of viscosity, fluids are divided into two types, Newtonian fluids and non-Newtonian fluids. So, what is Newtonian fluid? The fluid which obey the above relation, यानी कि fluid which follow Newton's law of viscosity is called Newtonian fluid, whereas those fluid which do not obey or which do not follow Newton's law of viscosity above equation is called non-Newtonian fluid. Then what is Newtonian fluids? So fluid that obey Newton's law of viscosity, that is shear stress is directly proportional to the rate of shear strain or velocity gradient, are called Newtonian fluid. In this Newtonian fluid, viscosity remains constant regardless of shear rate. For example, water, air, gasoline, petrol, diesel, kerosene and mercury. Then what is non-Newtonian fluid? Fluid that do not obey Newton's law of viscosity, that is shear stress is directly proportional to rate of shear strain or velocity gradient, are called non-Newtonian fluid. So in non-Newtonian fluid, viscosity changes with the rate of shear strain. For example, toothpaste, blood, milk, paint, ketchup are the examples of non-Newtonian fluid. Further, non-Newtonian fluids are classified into pseudoplastic, also called shear thinning fluid, dilatant, also called shear thickening fluid, and Bingham plastic fluid. So, in pseudoplastic, viscosity decreases with shear rate. In dilatant, viscosity increases with shear rate, whereas in Bingham plastic requires yield stress to follow. So these are the Newtonian as well as non-Newtonian fluids. Then what is the variation of viscosity with temperature? So basically temperature affects the viscosity. So the viscosity of liquid decreases with the increase of temperature, whereas the viscosity of gases increases with the increase of temperature. So this is the plot between viscosity versus temperature. So for gases we can see that with increase in temperature, viscosity increases for gases, whereas for liquid with increase in temperature, viscosity decreases. So this is due to the reason that the viscosity forces in a fluid are due to cohesive and molecular momentum transfer. So in liquid, the cohesive forces predominates the molecular momentum transfer due to closely packed molecules, and with the increase in temperature, the cohesive forces decreases with the result of decreasing viscosity, whereas in case of gases, the cohesive forces are small and molecular momentum transfer predominates. So with the increase in temperature, molecular momentum transfer increases and hence viscosity increases. So this is the effect of temperature on viscosity in the case of liquid and gases. Now what is compressibility and bulk modulus? So basically compressibility is the reciprocal of bulk modulus. Bulk modulus, which is denoted by symbol K, which is the ratio of compressive stress to the volumetric strain. So bulk modulus is the ratio of increase of pressure to the volumetric strain. So we can say that compressibility is the reciprocal of bulk modulus. So compressibility is equal to 1 by K. Now what is surface tension? So basically surface tension is defined as the tensile force acting on the surface of a liquid in contact with a gas on the surface between two immiscible liquid such that the contact surface behaves like a membrane under tension. And the magnitude of this force per unit length of the free surface will have the same value as the surface energy per unit area, and it is denoted by the Greek letter sigma, and in MKS unit it is expressed as kilogram force per meter, while in SI unit as Newton per meter. So, we can say that surface tension is a line phenomena and which is defined as the ratio of force per unit length. The phenomenon of surface tension is explained by this figure. Here, three molecules A, B, C of a liquid in a mass of liquid. The molecule A is attracted in all directions equally by the surrounding molecules of the liquid. Thus, the resultant force acting on molecule A is 0, but the molecule B, which is situated near the free surface, is acted upon by upward and downward forces. So, which are unbalanced. So, a net resultant force on molecule B is acting in the downward direction. The molecule C, situated on the free surface of liquid, does experience a resultant downward force. All the molecules on the free surface experience a downward force. Thus, the free surface of the liquid acts like a very thin film under tension of the surface of the liquid, act as though it is an elastic membrane under tension. This phenomenon is called surface tension. Now, I will discuss what is pressure. Basically, pressure is the existence of mass in nature. Mathematically, it is defined as external thrust per unit area is called pressure. Its unit is Newton per meter square. Other unit is Pascal, kilogram force per centimeter square, bar, psi and atmospheric pressure. And 1 Newton meter per square is also called 1 Pascal, and 1 bar is equal to 10 to the power 5 Pascal, and 1 atmospheric pressure is equal to 101,325 Pascals. So, there are different types of pressure: atmospheric pressure, absolute pressure, gauge pressure and vacuum pressure. With the help of this figure, I will explain what is atmospheric pressure, what is absolute pressure, gauge pressure and vacuum pressure. So, basically atmospheric pressure, this one, is the pressure exerted by the environmental mass, is known as atmospheric pressure. Then what is absolute pressure? This line and this line. It is the total pressure of the system measured from this zero pressure line. It is the total pressure of the system measured from zero pressure line. Then what is gauge pressure? It is the pressure of the system above the atmospheric pressure. Above the atmospheric pressure is called gauge pressure, and the pressure of the system below the atmospheric pressure is called vacuum pressure. So, these are the different pressures. Then what is Pascal's law? So, basically pressure applied according to Pascal's law, pressure applied at any point in a confined incompressible fluid is transmitted undiminished in all directions throughout the fluid. So, the applications of Pascal's law is hydraulic jack or lift. With the help of a small force applied on a small piston creates a large force on a larger piston. Then hydraulic brake system, force applied on a brake pedal is transmitted via brake fluid to apply pressure on brake pads. And the third example is hydraulic press, used in forging, molding and metal forming operations. So, these are the applications of Pascal's law. Then what is continuity equation? So according to continuity equation is based on the principle of conservation of mass for a fluid in motion. It states that the mass flow rate of a fluid remain constant from one cross section to another in a streamline flow. They basically continuity equation tells about conservation of mass. For compressible flow, mass flow rate at section 1 is equal to mass flow rate at section 2, means rho 1 A1 V1 is equal to rho 2 A2 V2. If density of the fluid is constant, so we can say that A1 V1 is equal to A2 V2, means flow rate या discharge at section 1 is equal to flow rate या discharge at section 2. So this is about continuity equation. So this is all about for this lecture. Thank you.